Everyone. In this video, I'm going to demonstrate how to do game 4 from prep test 34. All right, so we've got a bunch of conditional rules for our 6 players that are in exactly one of 2 clinics, either S or R. So our players, J, K, L, N, O, and P, have to be split up. They're either in S or R. Okay. And then we've got our conditional rules. So the first one, if is in the middle of a sentence, but we know that if is going to introduce the sufficient condition, whether it's at the beginning of the sentence or in the middle. So we're going to start if Juarez is at Sutterton. So if JS, then KR, KS, then JR. Okay. Rule 2, if JR, Juarez is at Ransboro, then OS. Oh no, is it Sutterton? Okay. OR to JS. If LS, then both N and P are at Ransboro. Contrapositive, we want to negate that. So NS, negate the and, it becomes OR. PR becomes PS because they only have 2 options. So the negation of being an R means that you have to be an S. And if L isn't an S, then L is an R. If at any point there's any confusion, you just let me know in the comments, okay? If NR, then OR, OS, then NS. 5. If PR, then KS and OS. And the contrapositive, if KR or OS, then PS. All right, so might want to take a moment to just double check that. I'm going to do that. So I'm just going to pause and read through. S, LS, NPR. Okay. NR, got that. OR, so OS and S. PR, then K and O, S. All right. So there's one mistake that I caught. Maybe you caught it as well. Right here, put an S, that should be an R. Okay, there we go. That's why we double check, right? It would be a shame to start getting questions wrong, have no idea what the issue is with that, just because I made a silly mistake in my rules. All right, getting into the questions right away. If you haven't attempted the questions yet, then I would recommend doing that before you watch the rest of the video. Question 19. You can do process of elimination for this one. So we're looking at the list of doctors that are at Sutterton here. So any doctors that are not listed, we can infer that they must be at Ransboro for that example. So J and K together at Sutterton, not going to be allowed. So that breaks rule 1. Okay, so we found a rule breaker for rule 1. Okay. What about rule 2? Rule 2 would say that we have to have at least one of O and J at S, right? If J is at R, O has to be at S. And if O is at R, J has to be at S. So at least one of them has to be at S. So E is going to break that rule, okay? Because we have neither of them at S, which would put both of them in R, and that's not allowed. We found the rule breaker for rule 2. Rule 3, if L is at S, then both N and P have to be an R. So if we see L and S, N and P should be an R. The only time I see L in S is answer choice C, but I don't see N and P there. So we can infer that they are in R, which would follow that rule. So that looks fine. Rule 4 says that N and O are together unless O is in R and N is in S. So, yeah, we can't have O in S without N. So C breaks that rule. So far it's this one broke rule. Or sorry, this rule breaker was A, this is B, C. Rule 5, if we don't see P in this list, then we should see both K and O. So D breaks that rule. All right. Okay. So that makes B the correct answer. So let's go ahead and add that to our bank of acceptable solutions and can erase this. So yeah, if you're wanting to keep track of a bank of acceptable solutions, I definitely recommend doing that. It can come in handy. So our first one here, we've got J, N, O, and P. And who's missing? J, O, K, and L. So they must be in R. So this is S, R. All right. And a big check mark next to it. Okay, question 20. If P is at R, then which one of the following must be true? So PR, I go down my list of triggers here on the left side of that line, and PR right there tells us that K is at S and O is at S. Okay. K being at S puts J at R. Okay. O at S puts N at S. And once we know N is at S, we know L is at R, and we've accounted for all 6 of our players. So we have another acceptable solution, which is P, J, L, K, O, N in R. So P, J, L in S and K, O, N in R. So what must be true? Whereas at Ransborough, A is the correct answer for question 20. A. Keep that. Let's use the eraser here. Okay. What is the minimum number of doctors that could be at Sutterton? So I would look through my consequences here. So we could have both J and K at R. Okay, so we're trying to push as many into R as possible and keep as many out of S as possible. We have to have at least one of these in Sutterton, right? O and J. So J is already in R, which means let's put O in S. And then all of these guys are allowed to be in R together. So there's no issue with that. The only issue we're going to come across is putting P in R puts K and S in O. So we would have to move K over, which is definitely not ideal. But if we do that, we could have J, L, N, and P in R. Let's double check that this works. So OS, OS means that N is in S as well. So that's 3. Okay, so putting O in S gives us 3. We do know that we have to have either O or J in S. So let's see if we put J in S, if that's any better. So put K in R. If J is in S, it's okay for us to put O in R. O being in R doesn't trigger anything. N could be in R as well. Let's see. So if K is in R, P has to be in S. So we are up to 2 here. Our final player is L. And L can be in R with N. And in fact, P being in S pushes L into R. So it would have to be, so 2. 2 is the minimum number. And this is an acceptable solution that we can add to our bank. So I'm adding this one first. So we did do that work, so might as well keep it. Right. Right. All right, moving on. Question 22. If N and O are at different clinics, O is at R and N is at S. O being at R puts J at S. J being at S puts K at R. K being at R puts P at S. P at S puts L at R. So what must be true? J has to be at S. Oh. Okay, so A is the correct answer for question 22. Let's add that one to our bank. Question 23. Which one of the following cannot be a pair of doctors at Ransborough? So these are 2 that can't be together at Ransborough. So if one of them's at Ransborough, the other one is pushed to Sutterton. So an example of that relationship would be the relationship that we have here between O and J. Right, so we could have both of them at Sutterton, but we can't have both of them at Ransborough. J's at Ransborough, O has to be at Sutterton. If O is at Ransborough, J has to be at Sutterton. All right, J and K, can they both be at Ransborough? They can, according to this rule. Let's just double check that there isn't something in the rest of the rules that would prohibit that. So J and K both at R. This one we could also use our bank, but we don't have any examples yet where we have J and K at Ransborough together. So probably a good idea to check that, test that out. Just in case there are other rules that prohibit it. So J at R pushes O to S. O to S means N is also at S, and at S pushes L to R. L at R doesn't push anybody anywhere. Our remaining layer is P. So P, let's see. Yeah, there's the only thing that would push P anywhere would be L at S, which it isn't, it's at R. Or oh, sorry, K at R. Yeah, K at R would push P to S. There we go. Okay, so that's another acceptable solution. But because it's acceptable for J and K to be a pair of doctors at Ransborough, to be together at Ransborough, that means that A isn't the correct answer. Okay, we can also create a chain here. So let's start with JS. We'll go KR, KR goes to PS, PS goes to LR, and anything else there? KR, PS, JS, KR, OR here. Anything else I can get out of this? Who am I missing? N. So how could N get on board? NR would push to OR. And then, yeah, so let's see what we can chain up. So J and P at Ransborough together. Yep, that would be fine. If we did the contrapositive of this, we would have LS to PR to KS, JR to OS to NS. So P and J together at R would be totally fine. K and O together at R, we see that's fine here. N and O together at R, that's also fine. So N and P, that's got to be the problem. And yeah, we can see here if N is at R, P has to be at S through this chain. Okay, so E is the correct answer though. That's the one that's not going to work. All right, we can leave that chain because that might prove handy for this last question. If K is at S, which one of the following must be true? So K at S, JR, OS, NS. So NS, B is the correct answer for that. We didn't really end up using our bank of acceptable solutions. It's a good habit to get into, but yeah, this game just made more sense to do the chain. So yeah, you'll get a feel for it, and at some point you'll get fast enough that you could use one of like multiple different methods to get to the correct answer, and you would still be within time. So the biggest thing is just making sure that you understand the conditional relationships and that you don't go backwards, right? You don't go from necessary condition to sufficient condition. You always start with knowing the sufficient and then inferring the necessary. And then you can use the contrapositive in that same way as a trigger and consequence as well. So you have the negation of the necessary condition leading you to the negation of sufficient condition. All right. Yeah, I hope that's helpful and not too confusing. I'm still kind of getting used to using my iPad instead of paper. So I might switch for another video, but yeah, I hope that that's still like legible and helpful. All right, I'll let you go. Any questions, just go ahead and leave a comment.